So we're going to go over a bunch of electronic parts. Remember, I've talked to you all about electronics is a lot like Legos, and once you start kind of understanding how the different pieces work together, you can make a whole bunch of different things. So hopefully in your notebook we started it. If you did not, do so now. Don't worry, we'll go through each one individually, but you basically are going to need a total of 3 columns. The title of this is components, which I'm misspelling. And the first one's going to be the part name, and then I'm going to show you the symbol for it, and then finally we'll talk about the job. So I'm not going to be writing the job out. Your job is to be able to put what I discussed in your own language on there. So the first one that we start with is the resistor. So this is a resistor. This is also a resistor. This is a resistor. And if we were doing super small ones for microprocessors, you also have one. Bring it in closer here. So these little thingies, let me see here. Where are my LEDs? Those are my LEDs. These little thingies right here are also resistors. So they can come in a variety of sizes. You've already done the assignment where you've learned how to read the resistor code by looking at the colors of the resistor because it's too small to write the words onto there. But sometimes you have resistors that are a little bigger. This one can handle more power, so it's actually a fairly small resistor, but this one can handle 25 watts of power, where this one is only handled, I think it's like 10. It basically is how much current it can go through. So all of these resistors, basic building block of electronics, and it's used to control the flow of electrons. It's like getting different size pipes. So the symbol for the resistor, if you did not get that, all of them have the same symbol, and it is looks sort of like that. On the PowerPoint you all saw, it also showed a potentiometer, which I forgot to grab. All right, so a potentiometer, this would be an example of potentiometer. Notice how it has the 3 little things versus the resistor, which just has the 2 legs. The big thing about all resistors is it really doesn't matter what direction you put it in the circuit, it works the same way. What a potentiometer does is a variable resistor. That means I can turn that knob and it'll adjust how much resistance it has. So looking at that on the paper, the symbol for that looks like this, but then it has a 3rd prong like that. So if I connect to the 2 outside pins, I get the maximum resistance. So this one's a 10K, so that means it has 10,000 ohms of resistance. But if I use the middle pin in one side, then it does a varying amount, so it can go anywhere from 0 to 10K on that. So that's a potentiometer. One of the places you see a potentiometer, if any of you have a dimmer switch in your house, that is a form of a potentiometer. Okay, the next one on here that we have is the capacitor. The symbol for a capacitor, it has 2. It has just 2 like this, or it could have like this. So the big thing about the symbols is, do you see how this has symmetry on there, whereas this one has a side that's indicated? If it's one of these, direction matters. If it's like this, the direction you put it in doesn't matter. What that looks like here, this is a electrolytic capacitor, and if you notice, do you see how it has a little negative strip right there, and then not? The negative strip indicates the negative side. It also happens to be the shorter leg, but if you know the negative strip, then it doesn't matter if they cut it. So that's a capacitor. You also have, say, your ceramic capacitors that look something like this. And if you flip it over and look at the right side, let it focus, you can see there's some letters written on it. That's how you can tell its value. And this one, it doesn't matter what direction you put it in. So it would be the symbol of a capacitor that looks like this. On this one right here, for the value of it, it says it right there. This one's 1 microfarad. So there are our capacitors. All right, our next component that we have, oh, I forgot to tell you, resistor controls your current. A capacitor, it's your energy storage. It works as a delay mechanism. It can be used for timers. It can be used to make generate a wave function, but it also can be used to store energy. It does not create it, but it does store it. A diode is something that allows the current to only flow in one direction. So on that one, direction does matter, and the symbol for it kind of makes sense. It's an arrow, and it looks like that. And the easiest way to sort of think about this is sort of like a funnel. If you had like a funnel, and you put a little ball in it, the water could flow this way, but if the water tried to flow that way, it would cap it off. So the job of a diode is to only allow current to flow one way. We have two kinds of diodes. We have the Zener diode, and then we just have a regular diode. A Zener diode, see that little black line on there, right there? That's the negative side. And you can tell it's a Zener diode because it looks like a little glass bead. Then you have your regular diode. That's just this black thing. And do you see how it has that silver strip right there? That's going to be the negative side of it, and it allows the current to only flow one way. Now, there's a fascinating physics story behind how they took this and turned it into this, which is called a light-emitting diode. And this is actually one of the things that Einstein won his Nobel Prize for. Not making it, he wasn't able to do that. But he came up with a theory of how it works, and if you're really bored one day, ask me and I'll explain the physics behind it. Now, let's see if it'll zoom in here real quick and focus. If you take a look on the inside of it, there you go. You can see how there's like a rectangle flag. That's the negative side of the LED. The one that's a straight pull up, that's the positive. If you run your finger around the edge, you can feel right there is a flat spot. That's the negative side. But the way that always is true, no matter how cheap your manufacturer is the one that has that big rectangle flag shape. That's the negative side of your LED. And it stands for light emitting diode. Direction does matter because it is a diode. The symbol for an LED is just that of an LED, but you have little arrows showing that light is being emitted. Now, the color of the LED, that plastic, is just there to help you know what color it is. So you can have red LEDs, you can have green LEDs. This one is actually two colors. The center pole right here is the negative, and then if you hook up power there, it'll turn one color, and if you hook up power there, it'll turn the other color. That's one reason why the plastic is clear, because it depends on how you hook it up. But the plastic casing, let me throw that across the room. The plastic casing just lets you visually see without hooking up to power what color the LED is. It doesn't actually control the color of the LED. Now, one thing they did is they took those LEDs and they wired them up, and they made this little thing right here called a 7-segment display. So a 7-segment display has, if you count it, 7 segments. This is one of the most powerful tools we'll be using, because with this little guy right here, we can do all of the numbers and a good majority of the letters. So that's a 7-segment display. I don't think it actually has a symbol. It probably does. I just don't know what it is off the top of my head. Okay, next we have a basic switch. So this would be a push button switch. You push it and it closes. You take your finger off, it's open. So there's one switch on there. Symbol for a switch, that would be a switch. The one I just showed you is a push button switch, so it would look kind of like that, would be the symbol for it. And then we're going to use one on a whole lot that's called a single throw, double pull single throw switch, which would look like this. That's the switch part, and it depends which one you throw there. So those are sort of your symbols for a switch. Next, this is one we don't actually use a whole lot in our circuit design, but it is really important when you're working with electronics. This is a fuse. A fuse is a device you put into a circuit so that if you have too much current, if your resistors didn't do their job right and you had too much current going through, if you look really close, you see that little filament? It's designed to go pop if you have too much current so that the overflow doesn't actually damage your electronics. That's a fuse. Okay. On the LEDs, sorry, backing up a little bit, this is one of the boards we'll be using. You can also make them, they make them really small now. Those little thingies right there are also LEDs. That's a red one, that's a yellow one, that's a green one on there. On the switches, this is also a switch on there. And you can see right there are 7-segment displays. And buried in here is also a fuse that you can't really tell, but there is one in there. It's not really replaceable. Okay, so there's some of your basics. Next, this one's a dinosaur. This would be this is a vacuum tube. This is the forerunner to transistors and our transistorized logic. These are what the very first computers were made from. This is 1 bit of memory. Are you processing that for a second? This is what we sent folks to the moon with. All right, so this little guy right here is what we sent them men to the moon, making computers with these things, 1 bit of memory. It actually generates a lot of heat, and it works very similar to how a light bulb works. And the fact that if it gets too hot or burns for too long, it actually burns out. So it used to be that when you're trying to fix your computer, sometimes you'd go through a panel. This is why computers took whole rooms versus fitting into the palm of your hand. You'd have to find this one tube here to do that. Now these do still have a use and purpose. They get used a whole lot still, well not a whole lot, but some of your high-end speaker and stereo systems will use the vacuum tube because your music aficionados tend to feel like it has a warmer sound to it than the transistorized logic. So we aren't really going to do this a whole lot and use these in the class, but it's kind of a nice little historical perspective. Basically what this guy did, it did 2 things. It operated as a switch, and it also operated as an amplifier. So you'd send in a small signal and it would kick out a big signal. Turns out this had some room for improvement, and that's where they came up with the concept of the transistor. So we went from this to this. It's a big difference, isn't it? So transistor, there's the top view of it. You can see kind of that flat side there. It's got the 3 little legs. The symbol for a transistor is there we go. That's a transistor. It also works as a switch or as a amplifier, and then once again it is basically 1 bit of information. This right here is the basic building block. Now we're not going to be working a whole lot with the fine details of it, we're just going to use it. But this is the basic building block of all of our electronics. And when you wire this up in a whole bunch of different ways, you can get different things like an AND gate, an OR gate, a NOT gate. Don't worry, that's going to make sense to you later on. And yeah, so but it takes like 5, 6, or 7 of these to make an AND gate. Well, it turns out folks didn't want to have to wire 5, 6, or 7 of these over and over again. And actually, most of what you're seeing here is plastic. You can pop the casing off, which I'm not going to, but you can pop the casing off and you'll see that the electronic component is just a little small flake that's in there. So they took these and they replaced it with these guys. These guys are called ICs. They have different sizes. So that one has 14 pins. This one right here has 5 pins. That's a little 555 timer. One of these is an AND gate. Actually, I think these are D flip-flops. But you see how there's that writing on there? That's standardized with code numbers, and so folks can figure out what they are by reading the numbers. And inside of this is a whole bunch of these. I dropped the transistor, I can't find it right now, that are wired together in a certain way to behave in a certain function. So instead of having to do it independently, this is sort of like your cake mix. You took a whole bunch of transistors, that'd be like your raw ingredients, put them together so you didn't have to make them all the time, and there you go. Right next to the IC, once again, these ICs, it's a generic name. It stands for integrated circuit because it integrated a whole bunch of transistors to make a circuit. We also have an IC holder, and this is a guy that you can use so you can solder that directly into a circuit board, and then you can pop the ICs in and out if the IC breaks, burns out, or whatever. So there's an IC holder, there's an IC. IC stands for integrated circuit. So there we go on that. So we got the transistor, the IC holder, and then the final thing we have on there is a circuit board. So when we start practicing soldering, you can see right there, these are like your wires, and then you stick the little holes in the pins for your different parts. And that's what they look like. So there's some basics of electronics with some of the key symbols that you're going to need to learn. Hopefully you wrote down sort of a job description of what each of these things do over here so that you can match it later on. And that's your overview of components. And I finished that up without showing you my super cool thing. I just so happen to know somebody who knows somebody who used to work for Texas Instruments, and I know this is super dated. I don't know if you've heard of this archaic thing that they had before they had smartphones called a Palm Pilot. So this was back when Palm Pilots were cutting edge technology. And remember how I said that most of this is casing and inside of there's a little plastic chip? Well, what they do is they actually grow these in silicon towers where they combine this. They're designing the circuits at the atomic level. So right there, see that little square right there? That right there is the whole circuitry brains for a Palm Pilot. So like in your phone and stuff, like all the brain stuff, memory, that's where it is. And the reason it can be so small is because the circuit's pretty much being designed at the atomic level. Does not use very much current. There's a lot of current, very little current with digital electronics. And they grow these in big towers, so you can see this on here. So this little disc right here, which concerning Palm Pilots are now obsolete, is probably not worth anything. But back in the day, you can see each one of those little chips would have been one Palm Pilot, which is was $200, $300 item. Now this one just so happened to have the electrical engineer had made a little oopsie, and it has a design flaw on it. So it actually ended up being trash, which is how I ended up getting it. So just kind of give you an idea of that is how they grow the circuitry for the insides of your computers, your microprocessors, and the more complicated things. So we went from this, which is one bit of memory, to the transistor, which I threw somewhere. There we go. I found it. Boom. The transistor to this, to wiring a whole bunch of these up to make this, to connecting a whole bunch of these up to make one little thingy of this that we put together and is the brains behind your smartphone, your computer, all the other stuff.